Here's another question submitted by a student, a question about some properties of integration. So pause the question if you want to have a go at itself. It says we have a graph of a function y equals f of x, where f of negative x equals negative f of x, so it's basically got some symmetry about the y-axis. It's shown below. The graph intersects the x-axis at x equals a, x equals 0, and x equals b. So it says identify a correct expression for the area of the shaded region, and gives us a bunch of options. So pause the video, have a go at it yourself. Alright, so looking at the problem, we need to know some properties of integration to have a go at solving this problem. So what we know is if we have a definite integral between a and b, if we switch the numbers around, a and b, so it's b and a instead, becomes negative of that integral. Okay, so you can try that by subbing in some values yourself. You'll see that the subtraction will make it negative by doing it in a different order. So two other points is if we have a definite integral over an interval, that's the signed area. Okay, it takes into account positive and negative areas. But if we're after a physical area, we need to break up the area into some intervals and consider all of the small areas positive. So let's see what all that means in the context of a sort of similar problem. I've got a function here, sine x. If I integrate just over the whole region, I get 0. So from negative pi to positive pi, I get 0. Because this area is considered negative, and this area is considered positive. It's an odd function, like the function in the question. Okay, they cancel each other out. If I wanted to find the physical area, I would integrate from negative pi to 0, this little part, find out that it's negative 2, and then I'd multiply this by negative 1 to make it positive 2, because that physical area is 2. This other part, I'll just integrate from 0 to pi, get a positive 2 here, add these together, 2 plus 2 equals 4. Okay, so we're going to use these same ideas in that actual multiple choice question. So try and basically eliminate some of these options. So option A, just integrating from a to b of that function. Well, that's a positive area, that's a negative area. I can't just integrate over that whole region. I would get 0. So I'm going to discard that as a potential solution. So we'll look at option B. This is integrating from a to a plus b. So b is this distance. So a plus b will end up at 0. So this is really 2 times the integral from a to 0 of this function. So what do we think about that one? It's this area. It's a positive area multiplied by 2. Tick. Sounds good. That's actually the right answer, but we'll go through the other two too. In option C, we're integrating between 0 and negative a. So from 0, a is already a negative number. Multiplying it, make it positive, actually makes it b. So we're doing 2 times integral from 0 to b of this function. Okay, but the problem is this is a negative area. So this expression's saying 2 times some negative will give me a negative value. Okay, so I want an area which is a positive area, so I'm going to discard this one as well. Okay, and finally option D, we're integrating, so it's negative 2 times an integral. This integral is between b and 0. So between b and 0. I'm going to switch these around so it's an area that I understand, so it's between 0 and b, but because I've switched the bounds around, that's going to be a negative here as well. Okay, so let's see how we go. So negative 2 times negative, well, this definite integral is actually negative. Okay, so I'm going to end up with negative 2 times negative of a negative number will end up negative as well. I'm after an expression for the actual physical area. So this one's no good as well because it gives me a negative value. Okay, so you may not have been shown that property of integration. Sometimes sort of just falls off because it's not used so much, but yeah, there's how you can potentially attempt that problem. Sorry it took me a day or two to get you this solution. Okay, good luck with your exams.